Boom! We're
Hello,
back!
Hello!
So here we go. We had a nice chat, and we never filmed the fun stuff for the YouTube. We always filmed the boring stuff. So we're doing geometric sequences. So arithmetic is when you had a common difference. The big difference when you have a geometric sequence is you have what's called a common ratio. I'm looking for those words. There it is. Already underlined. You have a common ratio. So here's a geometric sequence. And if you look, it's like, well, it looks like it's going up by what, 8? Right? And then if you try again, oh, it didn't go up by 8, so it's something different. Actually going up by a factor of 3, so you're multiplying by 3 every time. And that's what we call the common ratio. I hope they stop with the drawer soon. All the other stuff's the same, like this is term 1. All the notation is the same. Define the common ratio, so like what all this big paragraph is saying is like, to find the common ratio, you need to divide 2 consecutive terms. So for example, you might go term 2 divided by term 1. And there it is right there. Here is term 3 divided by term 2. So as long as you're dividing 2 consecutive ratios with the bigger term number on top, you'll find yourself the common ratio. Oh, there it is. It's just that easy. There's 2 kinds of geometric sequences. There's an infinite one. And the same thing with arithmetic. We didn't get there. Sorry, arithmetic sequences. If you go ... that just means the pattern continues. So we're saying, hey, it's an infinite one. Goes on forever. This is finite because when we get to the 108, we just stop. So that's where the sequence actually ends. Those are just fun little theory things. So let's try some of this. So let's find a couple sequences. Let's keep them going. So what's the ratio here? If you go, 8 divided by 2, you get 4. So check, is it going up by 4? Is multiplying by 4 each time? Yep. So, boy, I sure chose a small number here. So 32 times 4 is what, like 128? Someone confirm?
No.
Yeah, and then multiply by 4 again, if you have your calculator. I don't have the answer. 502?
512, and then
2038? Thank you. There it is. This one here, this one's interesting because there's a negative sign there. So when you go term 2 divided by term 1, you're going to go negative 3 divided by 1. So you're going to get that your common ratio is 3. So that's your R. So this is actually called an alternating. It's an alternating sequence because you're going to notice that the negative sign is going to alternate. So when you go 3 times negative 3, you're going to get negative 27. And then you go negative 27 times 3, well, you're going to get a positive,
81.
81, thank you very much. And then when you go 81 times negative 3, negative 243. Thank you very much. Oh, thank you, you're welcome. Alternating sequence, amazing. Yeah. Okay, so it alternates because, well, the ratio is negative and we start at a positive, so it's going to alternate over time. This one is called a decreasing sequence because you can see it's going down, and when you find your common ratio, 4 divided by 8, that's a half, right? 4 over 8 is a half. So it's just going to get smaller and smaller. So you can go 2 times a half, you get 1. You go 1 times a half, you get a half, and then a quarter, and then eventually an 8th, a 16th. So if you were to graph those on sort of like a number line, you'd be like up at 8, and then 4, and then 2, and then like a half, and it keeps getting smaller and smaller, and that's 0. Will it ever actually get to 0 if you keep going? The answer is no. So eventually we'll talk about what that means. We call that a convergent sequence because it converges on a number. Like eventually it's getting closer and closer to 0 but never gets there. So that means if we're finding the sum, we can actually find the sum of that. If it's a divergent sequence, so down here we're talking about, they don't approach a constant value. So examples of that would be like A and B. Right? Like A is just going to get bigger and bigger. Right? So if you're not like going to get to a number and stop like C where you get to 0 at some point. B is the same thing. It keeps alternating, but it's alternating between really big, really small, really big, really small, but it'll never actually get anywhere. So that's more like coming units, but we're just setting up the language now. So I hope eventually we get to a formula. This one is a geometric sequence that neither increases or decreases because it's like, yeah, I just talked about it. So this is another alternating one. And we say it's divergent Okay, so if it alternates and it never gets to a number, we say it's a divergent sequence because it doesn't approach a constant value. Okay, so part C on the other slide, that's a convergent one. It's convergent on 0. Okay, so this is convergent. And don't worry if I'm going a bit fast. We literally have another lesson where we talk about this specifically. So just giving you a brief overview. All right, what's all this? Right, we already talked about that, so who cares? This is another example of a decreasing sequence, and it's convergent. So if you're looking for a bit more information on the convergent stuff, there it is. Eventually, really soon, we're going to get to a formula or something. Here we go. Now, we don't actually spend any time deriving the formula for this. I fondly remember my university math textbooks, and it'd be like, here's the formula. And then it would literally be like, it's obvious why this is the formula. It'd be like, the proof to derive it is quite obvious. Like, literally, I remember textbooks saying that and then looking and being like, I have no idea where this formula came from. So that's kind of the case here. The reason it's like this is the general term I'll briefly describe. Right? So it's like, you start with term 1, right? So what was the sequence that we had? Let's do this one. So let's say that's my geometric sequence. What's the common ratio? 2. It's just doubling every time, right? So it's like, well, how would you generate like a term in the sequence? Well, it's like, take term 1. And if I want to generate term 2, what do I got to do? I got to take term 1 and raise it to the power of, or no, wait, sorry. Take term 1, times it by the common ratio, raised to the power of 1, right? That would give me term 2. You guys agree? Yeah? And then it's like, to get term 3, if you start from term 1, it would be multiplied by 2 how many times? 1, 2. Right? So where does this formula come from? It's like, well, somebody just thought, like, if you start with term 1, how do I get like any other term? And then eventually you see a pattern. Well, it's like, well, it's R. It's T1 times R. And if I call this Tn, it's that same n minus 1 thing again. Remember how before in the arithmetic sequences we had like the d and it was n minus 1. It wasn't a power, but we had to go n minus 1. Why? Because term 1 is already there. So you're already accounting for term 1. So it's going to be n minus 1. Does that make sense? Sort of? Vaguely? If it doesn't, it's okay. What you really need to know at the end of the day, this is the formula. Yeah. It's not a goal in grade 11, pre-calc, even grade 12 to understand necessarily where the formulas come from. You see what I mean, Rod? Like, it's flickering like a mad dog.
I can not work out.
It's going to give me a seizure.
Not the right kind of Caesar.
Not the not the right kind.
Yeah, I'll have a look. I do have a lamp with
What is the right kind?
Yeah, any whatever you got. Forever that will be on YouTube. Now, what if this joke explodes? Like, viral joke.
No.
Some of you guys. Let's see. Determining a term of a given geometric sequence. Yeah, we only have the one formula, so it's going to be a short lesson after this. We have this formula. Only so many things we can do with it. Right, so there it is. We're going to find term 12. So we want to know term 12. So that means that n is what? The $1 million question. 12. 12. Very good. Let's see. This is term 1. So 512 is term 1. We could find our common ratio by going term 2 divided by term 1. So be very careful. Term 2 is negative 256. Term 1 is 512. And I got a bit of experience, and I know that that just reduces down to a half. So it's negative a half. Let me know if you guys disagree. Any questions that far?
No.
So A is just, well, can you figure out term 12? So sure I can. There's my formula. So I'm going to write term 12 equals term 1, which is 512, times R, which is negative a half, raised to the power of n minus 1. Now remember, this is n. So n minus 1 is 11. And you would just type that in on your calculator, thank goodness. So I recommend you do this part first. So go negative a half raised to the 11. Make sure you use brackets on your calculator. right? So that it doesn't mess up the sign. Overall though, should it be positive or negative? Like you guys should know, it's an odd power, a negative base, so overall it should be negative, right? So, and then take whatever number you get there, multiply it by 512, and somebody let me know so I don't have to look at my notes. Anyone?
Negative 0.25.
Yes, negative 0.25 or a quarter. So either answer would be acceptable.
So is the value only the part that the power applies to? You know,
Yes.
Okay.
Yeah. It's only right here. Yeah. If it applied to the whole thing, it would have to be written like that, with the brackets. Okay, and it's not. But that is a good question. I'm gonna erase that because I don't want anyone to think that's the case. All right. Part B is really fast. It says, well, is this sequence convergent or divergent? So it's alternating. Now be careful, because just because it alternates doesn't mean that it's not convergent. So convergent means that if you imagine like doing 100 terms, 1,000 terms, whatever, is it getting closer and closer to a specific number? What do you guys think?
It's getting closer to 0.
Ah, very good. It's getting closer and closer to 0. Look at term 12. It's negative a quarter. What's term 13 going to be? If you multiply this by a half, what were you going to get? Ah, it's negative a half.
Oh, it's 8.
Yeah, so it would be 1/8. So term 13 would be an eighth, right? And then if you take that 1/8 and multiply it by half, then you get negative 1/16. And then a half again, positive 1/32. And then if you do negative a half again, 1/64. And then negative a half again. So what's happening is you're alternating above and below 0. But if this is 0, you're going to go like this, like that. You're going to go always closer and closer. So you're just alternating sign, but ultimately you're getting closer and closer to 0. Do you see that? Perfect. So it's convergent. So you would just say, yeah, it's convergent because it's getting closer and closer to 0. And how do we get the answer? We literally had to think about it. And thinking sucks. Like, it's hard. But that's how you get the answer. Yeah?
I need
A hand?
because like I have no clue how to do uppers to the power of this calculator.
Oh, catch me after the lesson.
Okay.
I'm more than happy to help you. I know how every calculator in the world works, so I'll definitely figure it out. Just from over here, is that a scientific calculator? Ben? Is that a scientific calculator?
Yeah.
Oh, okay, yeah. There'll be a button, I know that one. Maybe Mason will help you out. Okay, here's a try it yourself. I don't think we need to do it. I don't have any answers for it either, so I would like to do this next example though. And then as long as we get that far for today, we're going to be okay. So we should be able to do it the next example. Okay. This is a sort of a long one. So determining the terms and numbers of terms in a finite geometric sequence. So first it's asking us, it gives us term 1 and term 5. And this is very similar. We had a question similar to this when we did the arithmetic sequences. We also know term 6 and term 2. So let's do that first. So I would draw a picture. Are we able to easily find the common ratio if we know term 1 and term 5? What do you guys think? Not really. So we have two options. We could draw a picture, or we could use the formula. Because the formula is like this. If we use the formula, well, we might have to do some guess and check, and I don't know how we feel about that. So I'm going to show it to you like this. Here's term 1. Here's term 2. Here's term 3. Term 4. Term 5. Term 6. Now, do we know any of these? Yes. We know term 1 is 5. And we know term 5 is 1,208. So, could we find the common ratio? I wonder. If you start on term 1, how many common ratios do you need to multiply by to get term 5? So let's see, 1, you multiply by r once, and then to get to term 3 again, and then to term 4 again, and then to term 5 again. So how many r's do we have to multiply by? 4. So I know that term 5 is equal to term 1 times r times r times r times r. Do you guys agree? Excellent. So we can start plugging in some numbers. We know term 5 is 1,280. term 1 was 5. What's r times r times r times r?
4R?
It's r, it's r to the 4, right?
Oh.
Right, same base, so you're adding up the exponents. So now you could solve for that. You could divide both sides by 5. And I have no idea. I'd have to look at my notes. If anybody beats me to it. 256? So you get 256 equals r to the 4. I wonder if anybody remembers how to get rid of a fourth power.
Just square root.
Close.
Ooh.
But yeah, you gotta do the fourth root. So whatever the power is, if you do the fourth root, that would get rid of the power. So if you do that, oh, what? Like, I should know this. 4. Oh, maybe, and maybe with your calculator, you gotta look for a button that looks like this or something on your calculator. But I got it here, yeah, it's definitely 4. Now here's the thing.
It's 4.
Yes.
Okay.
Yeah. Technically, it's plus or minus 4, but we're only going to take what we call the principal square root. Principal, I'm just going to say the principal root. That just means the positive one, okay, because there's 2 ways I can get 256. I can go negative 4 times itself 4 times, or I can go positive 4 times itself 4 times. So technically the answer is plus or minus 4. But we're just going to take the principal square root, otherwise this question gets really long. And what else is it asking us? So we found r, and we were trying to find term 2 and term 6. But now that we have r, could we find term 2 and term 6?
Yep.
You betcha. So we could just take term 1. So term 2 would be 5 times 4, or 20. And term 6, we'll just take term 5 and multiply it by 4. How about that? So term 6 is term 5 times 4. Sorry, no, is it 5,120? Is that right? Excellent. Now we're ready for B. Now B is quite a bit of fun. I can't wait. So it says the last term is 20,480. Exciting. So that would be Tn. How many terms are in the sequence? Wow. How many terms are in the sequence? Let's see. Oh, did I pre-write that one out? No, we'll just leave that. So Tn, what was it? 20,480. Right? We know r is 4. What was term 1? 5? Yeah? I just need to clear all this text I had. Just give me a moment. I'm just gonna delete it. Get out of here. Get out of here, text. Clear the whole thing. There. Yeah, that's exactly what I wanted. There. So any ideas how we might tackle this one? We know the last term, we know r is 4, and we know term 1 is 5, and we have one formula, right? So if I was you guys, I'd be writing this formula down and then staring at it and hoping for the best. Do you have enough information to plug in and maybe solve for something? They're asking us basically like how many terms. So they're basically saying, well, what is n? Aren't they?
Yeah.
How many terms? Right? This didn't come through. They should have said Tn. So if I plug in for term n, I plug in what I got. And then term 1 is 5. And then r is 4, and it's raised to the n minus 1. This is tricky because in grade 11, you guys don't really know how to solve equations when the variable is is a power. You'll learn these wonderful things called logarithms in grade 12, but right now we don't know. But we will be able to probably do a guess and check method. So let's see. We can divide both sides by 5. Let's just try to isolate this. So what's this number divided by 5? Somebody.
4,000.
Thank you very much. And it's 4 to the power of n minus 1. So, like I said, in grade 12, you have a really good way of solving this. In grade 11, we're just going to say, do some educated guessing and checking. We're smart. Some educated guess and check. What I mean by educated is like, you know, this is a pretty big number, so you're probably not going to say, well, n is 2, right? Because we know that 2 minus 1 is 1, so 4 to the power of 1 isn't big enough. So maybe you'll be like, oh, I don't know, try like n equal 9 or something, right? And if you try that, you're trying to see, well, if I plug in 9, is 4 raised to the power of 9 minus 1, is it equal to that? Someone let me know. 4 to the power of 8, is it 4,096? No? Is it, how close is it though? It's really big? Okay, I don't know. Maybe we should try n equals 7? Still too big? Okay. I'm just gonna write it down, but you guys.
4 to the power of 6.
So it's 4 to the power of 6?
4 to the power of 7 minus 6.
So 4 to the power of 6 is the answer or no?
Well,
Yes.
Yeah.
Yeah, okay. So this works. Yes?
yes.
So now be careful. It's 4 to the power of 6, but n is 7, right? So there. How many terms are there? There are 7 terms. Didn't take long for it to get gigantic. I'll just double check my notes. I also got 7. So we're happy. Now, I want to try a very similar example. There's a try it yourself. I could quickly hammer out an answer. Maybe I will. We don't have enough time to do this one today, but that's okay. We can just start off with it tomorrow. So I'll end the video there. And you guys are looking at exercise 3. And what does the calendar say for tomorrow? 1.4? Yeah, we'll see. We'll probably do 1.4. But we'll start off with that one example. Bye-bye.